Okay, so we can move to next speaker. Thank you again.
Thank you very much.
So next speaker is Emil Kryukov from the Russian Federation. The title of the presentation is Cancer Stem Cell Metabolism Studies in ACT116 Chemo-Resistant Lines. So please go ahead.
Thank you. Hello, everyone. Hope that you see me well. Hope that you hear me well. Yeah, thanks for such an introduction. As was already mentioned, I'll talk about the CSCs. You won't be a big surprise at all. I'll talk about CSCs and the aspects of metabolism studies for colorectal cancer. Obviously, we should start from cancer stem cells. These cells become a real problem in oncology for different reasons. They play some role in tumor plasticity, in survival, heterogeneity, resistance as well as other cells and objects, and so on. The thing is that CSC precursor can be different. The whole stem cell niche, or some progenitor cells, or even differentiated cells that start the de-differentiation process. Today we know a lot about it, starting from Professor Monaco researches. And what is important, cancer stem cells can self-renew, and they are the reason of tumor progression. It's a place of self-proliferation. So our idea in this research was to analyze the CSC pool in colorectal cancer, one of the most frequent oncological diseases in the world. Well, talking about the cancer stem cells, as it was already mentioned, they play a key role in different processes. Some of them are due to the mutations in apoptosis systems or kinases or some other factors, but one of the processes is the closest one to the therapy. This process is the chemo-resistance, and it waveforms. So it can be a real idea to obtain some information about the tumor chemo-resistance by analyzing possible metabolic shifts in presence or in absence of some therapy agent. This info also can lead us to the ideas and understanding of other global important therapy aspects, such as the tumor resistance itself, the cancer stem cell behavior, depending on each case, and also the therapeutic efficacy. And now I just want to mention some key aspects of the CSC metabolism. I tried to implement some coding here because the system works really fine for such a characterization, and also it's short and clear. Well, we know that there are polar states of cell metabolism. There are glycolysis or oxidative phosphorylation. The oxidative phosphorylation works fine for the cells to keep alive and to take care about themselves, while glycolysis can give us the info about active cell proliferation. The thing is that when the stress comes, what is shown in different stress factors, and chemotherapy is a huge stress factor for the cells. So the CSC metabolism turns out to become more glycolytic, just to maintain the population and to support the tumor cells they are around. And a good question is how to find out what state of the CSC metabolism is at the moment, and also how can it change, how can we measure it. So here comes a brilliant method for such shift definition. It is known as FLIM, or fluorescent lifetime imaging microscopy. There are some great method advantages such as speed, simplicity, efficacy, and even non-invasive approach. These are good ones. And this method can investigate the metabolic status and features by calculating the info from the endogenous metabolic cofactors and by their autofluorescence. One of them, and probably one of the famous, is NADH or NADPH. This is nicotinamide adenine dinucleotide. By obtaining the info of these cofactor-free and bound forms, lifetimes, and contribution in metabolism, we can get the info about the cell's metabolic status. We cannot say that this is the glycolysis. It's some shift to the glycolysis or to oxidative phosphorylation. Especially in comparison, it works really well. Also, it's very important to know that FLIM can be used in the application with other modern methods. Here I'll draw your attention to single-cell RNA sequencing. One of the most professional research groups in this field is Peter Karchenko group in Harvard Medical School. Well, in our collaborative project, we've implemented this method for neuroblastoma. Here's one zoopicoid, how it looks like. And the result of this method is a genomic atlas of cells and their populations. They can give us info about the wide receptors variety, The chemotherapy agent targets is the receptor, about some new malignant cell types that can be affected by the modern chemo that we don't know yet. And all of that turns to a chemotherapy range obtained by imposing the patient tissues to the whole genomic atlas. While using this method, we can predict plethora of chemo agents for the patient, and FLIM can easily check if the specific agent works fine or not for every single case. Returning to the CSCs and their characteristics, the first problem is to obtain the CSCs from the tumor material. There are lots of markers, but none of them is unique for colorectal cancer. So we use the most fundamental ones. Here are CD24, 44, 143, aldehyde dehydrogenase, and the site population marker with all the isotypes and inhibitors needed for that. The problem of marker specificity is solved, at least partially for this experiment, because we decided to work with the colorectal cancer cell line HCT116. But while working with the human materials, and we tried that in some pilot experiments, it will make you face this problem. So in our experiment, we tried to design the resistant line to be as reliable as possible. We cultivated it for 20 weeks of increasing 5-fluorouracil dose up to 14-fold increase of IC50. Talking about the control for the experiment, we obtained the old one. This was cultivated in parallel with 5-fluorouracil line, and also the new one, freshly thawed. So for the 5-fluorouracil, I can notice the mechanism. The idea is pretty simple and it's fundamental, and because of its fundamentality, it can be really toxic. So this agent simply blocks the processes that lead to the DNA and RNA building. It causes the nucleic acid damage by embedding in the chains or affecting the thymidylate synthetase of it. And the idea was that in such a way, when 5-fluorouracil affects on the cells, we can observe the metabolic shifts for the CSCs and even non-CSCs to analyze the tumor response. For the cells obtaining, we use the flow cytometry method with all the protocols needed for the preparation, staining, and the cultivation, and also with the marker panel that we've chosen. Also remembering the specificity problem, it's really what we use. And first of all, it's necessary to give some response for the ALDH staining. We've got very strange results for the control groups, and this result can be due to the enzymatic activity of ALDH. It doesn't work as CDs do. So the time of experiment, the cell's activity are the crucial factors for the experiment. And if the first one can be regulated, you can just simply increase your speed of research, of working. So for the second one, we need some additional studies. Then we'll turn our attention to the CDs panel. Well, it worked, but obviously we found some great information about the HCT116 features. There are 100% of positive cells for CD24 and for CD133 controls. What does it mean? We cannot identify all the cells as the cancer stem cells. And even the positive result here can only give us a fact of its, such as stemness predisposition, if it's not simply expressed here. The only one CD I've shown here that worked fine and can show us the reliable data is CD24. And so here, from all the markers that we had at the start, we came to the idea of CD24 and site population positive signals for cells to be identified as the cancer stem cells. And here we meet the first idea that 5-fluorouracil leads to the decrease of the CSC amount. And obviously, it's really logical. The chemo agent leads to the active proliferation, and the CSC pool becomes pool due to such an active process of proliferation. Also, the site population analysis showed us pretty the same results. The 5-fluorouracil cells amount decreases, but we've seen the significance only for the new control, not for old one that can give us such information because of a long cultivation that showed us very low specificity. So yeah, by far we can tell that some markers are not recommended for the work with HCT116, some due to the enzymatic activity, some due to the line features. And for the resistant line, it is shown that the CSC amount is decreasing in comparison with the control groups. And then after obtaining the cells, which were sorted by CD24, it was a big decision for the optimal FLIM criterion. As you've seen previously, we can analyze our results by different parameters. We've talked about lifetimes and NADH contribution. So what about lifetimes? We can use tau mean of free, of bound NADH forms, also their contribution of free and bound NADH forms, and even the ratio of free and bound forms. Well, to choose the best, we've carried out some coding analysis that is shown in the densities. Here for the populations and for different parameters, for different criteria. The thing is that some criteria are more Gaussian-like and some are not. Also, the peak of the group can be easily observed or even blurred across the population. We can take for analysis the data with the blurred Gaussian and peaks, also blurred peaks, because these parameters may be not so influenced by 5-fluorouracil, or their range needs much more data to be observed, even if we got more than 100 observations for each group. Also, to check the distribution normalities, we've conducted Shapiro-Wilk test and built the QQ plots for our data simply using the R language. After all, we've decided that the best and the most accurate and reliable parameter for the shift definition is NADH free and bound contribution ratio. So here are some thin pictures for our data. And if we take a look at the plots for this data, we can easily see some correlation. The idea is that the higher is ratio, the more glycolytic is metabolism, especially if we remember that it's ratio of free to bound. Applying this knowledge to the plot, we see that 24 negative cells are more glycolytic than 24 positive cells, both for 5-fluorouracil group and both control groups. So here's the conclusion of this slide. Well, the second thing to be mentioned is observed when we look at the groups divided by positive or negative CD signal. In all the cases, the resistant group for 24 negative and 24 positive is more glycolytic. So the second part of the conclusions is about Flynn. Here is shown the most reliable criterion, most reliable parameter for the metabolic shifts definition. We've obtained the data that shows us the correlations. 5-fluorouracil cells are more glycolytic than non-5-fluorouracil. Resistant cancer stem cells are more glycolytic than non-resistant properly, and these results strongly correlate to the other articles and results we can find from different research groups. Well, and most of all, 24 plus cells are more exposed, oxidative-phosphorylated, than 24 minus cells. The 24 plus, 24 positive state, and the whole idea of CSC's role as a pool for proliferation, which can be active or not at the moment, correlated with this idea. And the role and the mechanism of non-stem cancer cells says about Warburg effect and their more glycolytic status. And also, to sum up, we obtained the algorithm for the work. Obtaining the cells from the tumor material in presence or in absence of chemo, such as 5-fluorouracil or some other chemotherapy agent, we can find out whether there are any metabolic shifts. Interpretation of these shifts and even the sorted cells amount they can also affect on our data can lead us to the ideas of tumor resistance or tumor sensitivity to the specific agent. Also, it gives us info about the state of cancer stem cells pool and prediction of chemotherapy response that plays an extremely important role in clinics. In addition, I'd like to express my gratitude to our entire team who worked closely on this project and made every effort to implement it. I'd like to thank my supervisor, Alexandra Kashina, for the invaluable contribution to my training and work progress, and special thanks to the Russian Foundation for Basic Research for funding this project. And here are some beautiful photos. The first one is of our Privolsky Research Medical University in Nizhny Novgorod in Russia. And the second one is the team of our research institute. If you have any ideas or suggestions for this or some other works, you can email me, and thank you for the attention. I'll be happy to answer all of your questions.
Okay, thank you for a nice presentation. I don't know if there are any question. I don't see in the chat. I don't know if someone want to ask any question, want to ask. Probably I don't see. Okay. So it's an interesting model. I'm just wondering, since for colorectal cancer stem cells, in tests being shown, there is a high expression of CD44V6, the variant of CD44. Did you check if there is any association in your model with the expression of this marker?
Not yet. It's a good question. We just need to check this in our further project. So these data can be interpreted in some other way, probably, if we get some results of it.
Okay. All right. So thanks a lot.